Hi all. In this Agentic Harness series, we will talk today about pattern, which Anthropic has recently introduced. Let's talk bit about Agent Harness. Agent Harness has been a recurring topic in the year 2026. It's also being called as harness engineering. So let's briefly touch what it basically means. So when we interact with harness, such as, let's say, a coding assistant like Cloud Code, or some general purpose agentic harness like OpenClaw, it seems to be more powerful than just the LLM. So LLM is at the heart of it. LLM and its reasoning variant, which is ability to observe, plan, act, reflect, is at the heart of it. But there is a whole lot of scaffolding around it. And the scaffolding is in the terms of ability to use tools. There is a cache, memory, as well as permissions. If it is a coding harness, there is a repo context, which is the workspace what one is currently working out of it, and there are certain specialized tools like Bash to which is a important component of programmatic tool calling, which gives us a ability to reduce the information going into the LLM context by doing many things at the bash command level. If we talk about the agent harness like OpenClaw, there are certain personalized evolving memory which learns. This is stored as in the form of either empty files and some other files like soul.md. Also, it provides integration with tools like Telegram, WhatsApp, so on and so forth. Now, one of the architecture pattern followed over here is that everything is in a single container. So what it means is that each container has an instance of a reasoning model along with all the frills, what is supposed to be there in the coding harness. Now you would have guessed that probably this is not scalable because it kind of creates a one-to-one mapping between the brain, if we refer to the reasoning model, LLM-based reasoning model as its brain, and the tools it has as its disposal. All of them reside in a single container, and hence it is not very scalable. The other aspect to it is that the brain, or the, let's refer to as the outer loop, like the cloud models, they are uh, becoming more and more capable as the time goes. A point made here is by comparing Sonnet 4.5 with Opus 4.5, wherein Sonnet had a context anxiety, which was something it kind of tend to uh, wrap task prematurely when its context limit was approaching. But that behavior was not there in Cloud Opus 4.5. So they have introduced something called as a managed agent, which is a hosted service and cloud platform, which runs long horizon agents on our behalf, and it is exposed via set of interfaces. And those interfaces are meant to be abstractions and also outlive the particular implementation of the interfaces. We'll briefly talk about the interface they are providing. They are saying that they are opinionated about the shape of the interfaces, but not what running algorithms. So when we talk about interface, we have a harness, which is the primarily the brain or the model. We have sandbox as another interface, session as another interface, orchestration as another, and MCP-based tool as another. MCP already is a well-defined interface. Um, so primarily, these three things have been newly defined. And the points made in favor of this approach is they are explaining it with an analogy, like a pet versus a cattle. A cattle is a generic term, and yeah, whereas a particular animal can be replaced with another. But a pet is very specific. It hasn't got a name, and hence it's difficult to kind of uh, replace it. So what they are saying is that the earlier approach was more like a pet, which had a few disadvantages. Like we don't know what gets wrong, number one. Somebody has to open the shell, and you can't open the shell because it contains user data. So that means it lacked the ability to debug. The second issue was that the cloud worked on whatever the cloud worked on, it lived in a container with it. So when the customer asked us to connect cloud to their private cloud, either they have to peer the network with Anthropic's network or run clouds harness in their environment. So one of the important aspects is decoupling the brain from the hands. So brain is the model, hands are the tools which can be used. So the container is decoupled from the harness and it becomes like another tool. So this makes it easy to recover from harness failures because since the session is being saved outside of the harness, any new container, any new harness can come up and it can assume the state what was saved in the session. There is the security to maintain the security boundary in this decoupled design. The tools which need access to credentials are kept outside of the harness and it's not included. So it is kind of proxied and it can fetch the credential from the vault and make call to external servers. And the harness is never made aware of any credentials. So in long horizon tasks, the context is exceeded most of the time. So one in the prior approaches, what was being done was like trying to compress the context or storing certain there was two versions of the context. One as a long-term memory and the second as a short-term memory, which has been defined over has been defined over here. Also, the other approach is that now there can be earlier there was the one-to-one mapping between the brain and the tools it was using. It now that has been decoupled to use many-to-many approach. So the claim is that this is a fresh take. Probably in the engineering world, this approach was always encountered, and modularization was was the way to go about it. I'm seeing this as a modularity approach, modularity-based approach, rather than a monolithic approach. So that's it for this architecture pattern. Thanks a lot.